Hello everybody and welcome to episode 11 of these NoiseMap tutorials. In episode 10 we illustrated some of the capabilities of the NoiseMap 3D viewer, but we did it on a 3D view that had already been generated. I'm going to show you this time how you generate a 3D view. And we're going to do it from the existing example model that comes with NoiseMap and you can access from the help menu. So we go to explore worked examples. Since NoiseMap is open, I can just drag the file onto the NoiseMap home screen and it will load it for us. And there we are. Yes, we'll want to continue with this. The screen's still blank. I need to go to the database preview and load it, and I'll load it for all the populated tiles, and there it is. Now when you generate the 3D view, it will be generated from whatever you're looking at on screen, so we need to make sure that we have the correct area shown on the screen, otherwise the 3D view won't be what we were hoping for. So let's include some noise contours and some receiver results. Let's have a look at what noise contours we've already got in the database, and let's look at the database contours. Well, we already looked at the road traffic noise, so how about the railway noise? Yes, we've got 6 tiles with valid contours, so let's choose those. And we just load those up. Then the properties screen opens and we need to decide what sort of contour we want displayed, because that's what's going to be viewed. And I'm going to stick with the blue, green, red and let NoiseMap choose the contouring for us. And this is the calculation of railway noise LEQ 1 hour data. That's fine. Now I'd also like to look at the receiver levels and have those coloured by noise level as well. So let's load some receiver results. Let's see what we've got. Actually, we only seem to have calculation of road traffic noise. So we need to do a railway noise calculation. So I want to calculate database receivers, and I just want to do it for these 6 tiles here. So it says select tiles to calculate. If I just click and drag in the tiles, they're highlighted and I'll calculate for those. And I'm going to do CRN LEQ 1 hour. These are the options and that's the one I'll choose. I don't believe there are any valid results, so we'll just do the calculation. So there are 6 tiles to be calculated. That's the first one. That's the second one. And the third one. And the fourth one. Obviously there are more receivers here, it's taking a bit longer. The 5th and the 6th, that's the last one. And yes, let's load those now. So there we have the calculated results for railway noise, and there they are, those 6 tiles. Green shows that they're valid, so we'll load those. There is, I believe, only one result set. Yes, there is. So we'll just choose that. Now, although the results are loaded, if I just zoom in a bit, You can see the receiver points are still blue, they are not showing the results. I need to show the results, so I need to go on View, Viewers Color on, and select Receivers and Results. Now, obviously, I haven't loaded the results for existing roads, but if I go down to here and choose trains, then you can see that the noise levels are shown ranging between 25.6 and 71.2. So let's update the view with those. I could choose the floor level. Let's choose floor level 1. And there we have the results in that range. And you can now see that the receivers are coloured according to the view. I'll go into move mode. You'll see that the front facades facing the railway are paler colours, they're noisier, and the rear facade, they're quieter. So let's zoom to the full model again, and I need to load the database contours as well. And I want to load them for the train scenario. I'll let NoiseMap choose the scale, and I'll just close that to get it out of the way. That only closes the dialog box. It doesn't close the results themselves. And the results are described here. It's manual example database with new road, and the contours and the receivers are shown here. The viewer's colour is correct for trains, but I want the receiver view also to be for the correct scenario. So if I click on expression here, double click with new road, but the combination I want is trains. Okay. Let's just zoom in just to have a look again. And you can see the receivers are coloured, and as you'd expect, the colours for the receivers are similar to the colours for the contours. So let's zoom back out again, and now let's generate the 3D view. So I go to Calculate, Generate 3D Files. It's offering to put them into My Documents, Demos. I'm going to call it Example Database 3D Example. Now, we also need to set up some of the 3D parameters. For example, where we're going to look when we start. We can put ourselves at a receiver if we want to, and we can set where we're looking. I'm just going to leave those, see what comes out. We do want to colour according to the headline result. I really ought to rename that, oughtn't I? I don't like the fact that this is saying receiver expression R1, so let's change that. We go to Calculate, Receiver Result Display Parameters, go to the expression generator here, and it's result R1 with new road, but I'd like this to say trains, so I'll just change that. So expression R1 is what we're going to plot, and it's going to be called trains. And that's now showing trains, and that's updated to trains. So now that's better. Let's calculate the 3D files. So We'll call this example. We're not too bothered about where we're looking from, but we do want to colour them according to the headline result, which is trains. And we do want to show the model and the noise contours. We want to include the current model view and the noise contours in the 3D view, so we have to tick both those boxes, click Save, and it's now generating the view. The view is made up of triangular facets, each coloured according to the noise level. So there will be thousands of facets, and the position and colour of each one is being worked out at the moment. The first half of them take longer, and it gets quicker towards the end because there's fewer things for it to assess. And it's saved it there in this directory. And what it will now do, it's saved that 3D view as an archive. It's confirmed that the overlay is saved as a bitmap in the same directory as the 3D view, and then it starts a 3D view, and there we are, just looking north towards the centre of the model by default. So the thing that we're really interested in is the railway, which is below us. You notice that the receivers are coloured according to the noise levels, and if I spin round I can see the railway. Now if I press M, that means that it follows the mouse, and I can use the keyboard to move, and also the mouse. I'll press A to slide to the right, and I can alter the position I'm looking in. Right, now to come down I can just fly downwards, forwards, and that's quite a nice view showing the noise levels on that block of buildings. Red being the highest, and you can see the colours shown in the scale on the right. It doesn't show the noise levels, it just shows the scale. Those are in fact the ISO colours, so they're perhaps not really all that brilliant for this particular job. And if I move the mouse wheel, I can bring myself down without moving my position, and then press W to move forward. Ooh, I need to go upwards a bit or I shall end up going underground. And as you'd expect, the railway is noisy. Going under the bridge there. Ooh. And we can see the noise levels on these receivers over here. And if I raise myself up by scrolling the mouse wheel forward, I get more of an overview of the area that I'm looking at. Let's have a look over in that big housing area up ahead. I'll press Shift to just speed up to get nearer to it. Let's go upwards and then move forward. Press W to move forward. And you can easily see the shadows, the blue, behind the houses. And you'll notice that the noise levels are quiet on the back. They're actually beyond the range for which there are calculations. In fact, I think that they haven't been calculated because they've got no view of the railway. It gets quieter as we move further away. Yes, so some of them have coloured white. I think that is, there's no noise level available for those. They are in the shadow of the railway. So we're looking now flying back towards the railway. And there's the dual carriageway, and we know that to get to the railway we really need to go back towards the roundabout. We can see the noise levels, the red noise levels of the railway there. But I'm moving the mouse wheel forward to go up, to elevate the viewpoint. The speckly green right in the middle or back of the view is the ground, where there is actually no noise contour calculated. Press shift just to speed up a bit. So that can be very useful. Apart from anything else, it does show you whether there are any errors in the way you've modelled this. And as you can see, on a fairly simple model like this, it was quick to do as well. Press D, I can move back over the railway. W, let's go forward again. Those of you who are used to computer simulation games will probably find this a lot easier than I do. But I'm not normally trying to generate a racing car simulation. I'm just trying to spot what the results are. And that's the end of the model there. Fly off into outer space now. Let's turn around and look back the way we came. So I think you can see that 3D view shows you an awful lot. So I'll leave it there, and thank you for watching, and hope to see you again soon. Goodbye.